of the kind that you saw on the previous slide will be implemented using a variety of technologies. And typically, you can categorize or organize technologies um, according to the layer in which these technologies apply. Although some technologies will cross layers as well. Okay, so you can think of technologies that work at the presentation layer. So the technologies that work in the browsers or the desktop applications or the terminals. Typically, these would be technologies such as HTML or JavaScript or Java applets or Flash. And then there is technology for the business logic layer. So ASP.NET, um, let's see what else, Java server pages, JSP pages, or servlets. These operate at the business logic layer. Then there are integration technologies whose role it is to um, combine or connect different systems. And these technologies are examples of these technologies are message brokers, enterprise service buses, um, things like that, right? Then there is technology to access databases and data sources, and you might have heard of ODBC or JDBC or ADO.NET. These are technologies used to access repositories, persistent repositories of data. Um, then there are management suites. So think of all these enterprise applications running on a whole collection of hardware. On the hardware might be operating systems. In fact, each actual machine, each physical machine might actually have multiple virtual machines, each of them running their own operating system, things like that. And you need an application that manages this collection of systems as a whole. So, for example, if an upgrade needs to be made, a Linux upgrade needs to be made, you need to have a application that will that will upgrade all the Linux machines in your data center, as opposed to upgrading a few or having or forcing the user to upgrade each one of them manually. And it might do things like either all the systems get upgraded to the right version of Linux, or all the machines get backed out. And this would be an example of a management suite. Another example of a management application is something that monitors all the applications. So there's a data center administrator, if you will, who sits at his terminal or his dashboard, and he's able to see um, whether all the systems in his data center are actually working. And if one of them dies, he can click to that system and see what went wrong. Okay? And then finally, then there's the hardware. So and within the hardware, we include the networking infrastructure, your Ethernet, token ring, whatever that might be, as well as the actual servers with their own operating systems. So this slide talks about all the different technologies that fall into those different categories. So technologies that basically handle structured data. So XML is an example of that technology. Different technologies that handle the user interface or support the user interface. So HTML, Flash, and JavaScript. We talked about those. Technologies that basically support what is known as a rich client interface. So there the idea is, in an old style HTML page, um, every time you did something, the page got posted to the server and a new page got generated. Whereas with rich client technology, the same page stays and simply gets modified. So when you click on a list and the list expands, it's not as if a new page with the expanded list is shown. It is that the same page now shows an expanded list. And in order to do that, in this particular case, you might have to go fetch the data for the list from the server. So rather than sending the whole page to the server, you send a little message that says, "Give me the items in the list," and the server sends back the items in the list, and it simply populates the list and expands on the browser itself. And a technology like that, and an example of a technology like that is Ajax, which is the open source version, and then there is Flex, which is the Adobe version of the same kind of technology. Then there is technologies for the server layers or the business logic layers, and we mentioned a few of them during the last slide. Servlets, Java server pages, Java server faces, ASP.NET. We mentioned and then at the next level down, there are technologies that sort of abstract the database and present the database, which is a relational database, if you remember, tables with rows and columns, presents those as objects, and those technologies are called object relational mapping technologies. So enterprise Java beans or EJBs is an example of such a technology, of such an object relational mapping technology. Then there are technologies that provide connections to outside systems, and you might have heard of web services. You might have heard of technologies that connect systems within an enterprise, and that those technologies are known as message brokers or the enterprise service bus. There are technologies that connect to these old systems like mainframes, and those are legacy integration technologies. Then there are technologies that allow you to run parallel programs on either supercomputers or parallel computers or on a network grid of computers. And then there are technologies that support mobile computing, so PDA and cell phones. So Windows Compact Edition or J2ME. These are all technologies that support small devices. And then there are technologies that fall in the category of what is known as edge computing or sensor networks. So these are little devices that are placed outside in the physical world, and they can do things like measure temperature. They can measure whether somebody is walking by. Some of them have little radars that measure that can actually track objects. All those would fall under the category of edge computing. So the main point of this page really is that there's a whole collection, a whole slew of technologies that make up these enterprise systems, and it's probably beyond any one person's capability to learn all of these technologies, say while they're in school. Which is why what students should really try to learn in school are not specific technologies. Of course, though of course they're important and would probably get you your first job, but in addition, learn principles behind those technologies so that you can then understand newer technologies by sort of understanding the principles behind them, as opposed to having to learn each technology one at a time. Okay, so when you learn principles of programming languages, you can pick up any programming language, rather than when you learn C++, that's the only thing you know. This slide tries to make the point that enterprise computing or enterprise systems are by nature distributed, and that the distribution characteristic of the enterprise systems is not often deliberate, but simply uh, because of the nature of the enterprise. So, for example, um, if a company is geographically distributed and has multiple branches, then if you look at the enterprise systems that support this enterprise, chances are pretty high that each division or each branch has its own computer, runs its own applications. And therefore, the collection of enterprise applications that make up the enterprise system is by definition distributed. What could also happen is that there were two companies, each had their own systems. One bought the other, so now you have two companies each running their own systems that have now become one company, and it often is not practical or not appropriate to try and merge these systems and run one system. So this merged company continues to run a second system, but then these two systems are connected or integrated in some manner, typically because the financial information from both companies, both parts of the company, have to be integrated and presented as one. So the enterprise system ends up being distributed. Distribution could be also caused because of the physical separation of people. So if you think of a PDA that's issued to a salesperson so that he can make sales calls and actually complete sales while out in the field, and he's given a PDA to do that, well, that sales application is going to be distributed. So there's going to be a component that runs on the PDA, and then there's going to be a component that sits at the home server and runs there, and there's going to be some communication between those components. So when typically when students are taught about parallel computing or distributed computing, they are taught about distributed computing by design. So you take an algorithm and make it run in parallel and get speed up that way. And the point of this slide really is that deliberate design is typically not the reason why enterprise systems are distributed. It's simply because of their nature. They're just naturally distributed systems. And what distribution gives you or brings to the causes is complexity. So it isn't that you are just managing one single program. You're managing a collection of programs that are simultaneously running and collaborating with each other. Um, and any of these applications can fail, any of these applications can interfere with the other, things like that. And therefore, this distribution essentially means more and more complexity. So the secondary reason why enterprise computing or enterprise systems, why enterprise computing is distributed and why enterprise systems are distributed systems, the secondary reason is the computer science reason, which is when you have multiple computers, you can harness unused computational cycles, so you can break a problem into multiple parts and you can solve each part simultaneously on a set of parallel machines. Um, Once again, this might happen for specific applications. You might take an insurance actuarial application and run it on a parallel computer and parallelize it that way. But typically, just keep in mind that enterprise systems end up getting distributed not because of design, but because of evolution.